Hello and welcome to this tutorial. You might have seen CAD contests from other CAD packages, for example, Model Mania from SolidWorks. Now, OnShape offers you something similar with plenty of advantages. Let me show you. Here on my UI, I get this icon here, CAD Challenges. You might not have that, so let me show you in an empty Part Studio. I access the App Store here, go to search and type in CAD challenges. There are plenty of apps you can access. I will scroll down and find this one here, CAD challenges. Okay, there's a description, the web application seamlessly integrates, and so on. So you can add that to your environment, and once you have that, you have that little button here. I open that, and so there are plenty of challenges in Part Studio, multi-part, and assembly. For this video, I will choose the Arduino enclosure. There is a description, multi-part, Part Studio, okay, challenging, okay, number of times complete. This is very new, okay, so only 8 times, average time spent 21 minutes, okay. I have completed that before, okay, but for the sake of this tutorial, I will retry this. So the Arduino, is imported in our Part Studio. I will hide the planes here. And the challenge is to model the enclosure and 4 spacers. So we get this technical drawing here, a side view here with a connector, the slots and the front view, yeah, that USB port here, a top view with the flanges. We get a detail view cut around that USB connector, okay. And finally the spacers. Okay, we note that the dimension is millimeters. And now let's start with the spacers, which will sit here on that face. So I start with a sketch, take the line, the circle command, give that dimension of 7 millimeters. Make one more here. Oops, I got into construction. No. Here, 3 millimeters, right? 4 millimeters. Okay. And then an extrusion of a new body, thickness 3 millimeters. Okay. I'll rename that spacer. And check on that material here. Acrylic, right click, assign material, acrylic, there it is, accept that. We got our first spacer and we need to insert 4 of those. I will use mate connectors for that. Define that one here, next one over there, one more here. Go into the transform, take our first spacer, go to transform by mate connectors, take that one to that one as a copy. All right, and do that 3 more times. Mate connector from that one to that one as a copy. And one more time here. Bomb. Copy to that one. Press K to hide the mate connectors. And we got the 4 spacers. And now let's work on our sheet metal enclosure. So we got the dimensions here, 85 to 69. So I'll start a sketch on that face with the center point rectangle. Place that somewhere here. Open that here. Dimension that 85. And 69. With H, I place a horizontal relationship here. And sure, we can apply a coincident relationship to that outer edge of that USB cover or port. And that's it for that sketch. Or no, we should project the holes, right? So go back into that sketch, press U, and take those edges here. All right. And now let's have a look at the sheet metal tools here. I go to sheet metal model, go to thicken, take that face here, have a look at the definitions of that. So the thickness is 2 millimeters. I get it in there. The band radius is R1. I got that. And the direction of the extrusion is fine. So I accept that. Well, that wasn't too well done here. Looks okay. So edit, add that. Okay. So that is our part 5. So I call that enclosure. And change the material or assign the material to aluminum. Aluminum. There it is. Accept that. Next, let's define those two sides, side flanges. So there is the tool. There is the edge and that one. Turn that around. And now we want this to be inside. So that is our outer definition. Distance is 32. And that's it, huh? Accept that. And do that one more time. Flange. Take that edge here and that one over there. Distance is 25. And the alignment again is outer. There it is. Accept that. Then let's go into the chamfer here. Distance is 10 by 10. 10 equal distance, and pick those corners. All right. Let's define those holes on that face here with a point command. Place 4 points. Take that. And make those H horizontal constraint, V vertical constraint here, and D for the 60 millimeters there. 60. 10. Those holes align with those edges. 10. Okay. And what else? Again, 10. And one more time here. 10. Accept that. Go into the hole command. Simple hole through wall. And that is 5 millimeters, huh? 5. That one. That one. Okay, I get an error here. It's not 10, it's 12.5, huh? 12.5. Okay, we got that part. Let's work on those slots on the side here. Take that face, take the line command, draw a horizontal line, make that construction geometry, and so we get a 12 millimeter distance here. We get a length of 25. We get a vertical limit here, 7. Fully constrained. Let's go into the slot command. Take that line here, and there is a 1.5 radius or 3 millimeter diameter. And I'll just go ahead and extrude that, sketch through wall, through our whole body here, no? Doesn't interfere with this here. And there we have that. Then let's pattern that. Feature pattern, extrude, direction, go this way. Distance is 6 millimeters here. We need 4 instances. All right. And we need now repeat that. So there's the 11 millimeters, there's the 25, that makes 36. So I'm gonna second direction, take any line in that direction, make that 2 instances and 36. And there we have that. Okay. Let's continue with those front and back flanges. So our command, take that edge here and that one, define that end type by up to entity here. Take that face there. All right. And about the alignment, that should be inside here. All right. Band angle 90 degrees, everything's okay. Accept that. Finally, we need to work on this detail here. So that's on this face. I start a sketch here. I see those edges here of our USB. Take all those here. Make that construction geometry. Then offset those 3. with 1 millimeter, huh? And go into the extrude, remove, up to next, huh? Merge scope is that one. Okay. And let's just check our drawing one more time. Maybe we hide our Arduino. There are those 4 spacers. There's our sheet metal enclosure. And, well, once we're satisfied, let's submit our design. And you receive your ONshape CAD model matches all expected values. Great. Okay, I needed 21 minutes. Okay. And that's it. Well, I checked on this app, the CAD challenges, a month ago, and there were much less challenges. So really, this is developing right now, and I just wanted to share that with you. I think it's a great way of developing your skills. And I might do another tutorial on some parts. As always, if you like the video, you can subscribe to my channel, like and comment, and I see you in the next video.